Okay, number 2, we're asked to sketch the region in the plane described by this system of nonlinear inequalities. So let's look at each of these in turn. Let's look at the first one. I've got x squared plus y squared is greater than or equal to 9. So the boundary curve in question is going to be x squared plus y squared equals 9. And since I'm allowing equality here, when I sketch this curve, I'm going to leave it a solid line. So I think back to chapter 7, I recognize that the graph of this equation is a circle centered at 0, 0 with a radius of 3. So I'll do my best to artistically depict that. And this curve separates the plane into 2 pieces, and I've got to figure out which pieces are satisfy the inequality. So we take a test point. Let's pick a test point inside the circle. A convenient choice is 0, 0. If I plug 0, 0 into the inequality, is it satisfied? And the answer is no. So that means I'm not going to be shading inside the circle. So it appears as if we'll be shading outside the circle. But to double check, let's take a test point outside the circle. Say 4, 0. Is 4 squared plus 0 squared bigger than or equal to 9? The answer is, of course, yes. And so the solution, or the set described by this inequality, is that. Okay, so it's a circle and everything outside of it. Now let's go check this guy out. We've got x squared plus x squared over 25 plus y squared over 9 is less than 1. So the boundary curve here is that. Hopefully we recognize from chapter 7 that's an ellipse centered at 0, 0. We go 5 in the x direction from the center and 3 in the y direction from the center. And I really shouldn't be filling these dots in because it's a strict inequality. That means when I dot the when I go to graph the curve, I'm going to be dotting it in or dashing it in. Okay, so that's an ellipse. So let's take some test points. A convenient point inside the ellipse would be 0, 0. And so if I plug 0, 0 into the inequality, I get 0 squared plus 0 squared. Is that less than 1? The answer is yes. So it means I'm going to be shading inside the ellipse. And pick a point outside the ellipse. I could pick 6, 0. If I plug 6 in for x, I'm going to get 36 over 25 plus 0. Is that less than 1? And the answer is no. So that means I'm not going to be shading the outside. So geometrically, what do I want? I want the points that are outside the circle but inside the ellipse. Now we have to be careful here because, you know, just from the graphs, the circle and the ellipse would intersect at these points. All right, so if I go to draw the circle in here, I know the circle's got radius 3. Oops, radius 3. So if I go to draw the circle in here, I know I'm going to have at least those 2 intersection points. And so it looks like, once again, I have to have open circles here. It appears as if the region that I want, my solution to this, would be everything in here, everything I'm shading here in red. So it'd be everything on the circle except the y-intercepts of the circle, and then between the circle and the ellipse. Looks a lot like the Eye of Sauron from Lord of the Rings. Anyway, the thing we have to double check is if there's any other intersection points. So maybe the ellipse comes down here and cuts through the circle. Okay, so we don't know that from our sketch, so we have to check it. So we have to check for intersection. So to check for intersection, we're back to looking at a system of nonlinear equations. All right, is it possible to multiply by a number so that we can cancel off a variable? And the answer is yes. I can multiply the second equation by a -9. So multiply both sides by -9. Add them up. So I get x squared minus 9x squared over 25. Well, 1 minus 9 25ths is 25 25ths minus 25, or minus 9 25ths. And 25 minus 9 is 16. So I get 16 25ths x squared. This looks like this is going to be horrible, but just watch what happens. The y's cancel out. Everything's equal to 0. So we get x squared is 0, which means x is 0. So if I plug x equals 0 into either of these two equations, I should be able to determine what the y is that goes with it. So we'll just choose the first one. So by plugging in x equals 0, we're really looking for the y-intercepts. And we already know what these are. They're plus or minus 3. That means the only solutions to the system are 0, 3, and 0, -3. Which means that our graph is going to be exactly what we thought it would be. So our final solution, I guess we'll do it in blue. That's a soothing color. And as I mentioned, we're going to have open circles at these points because these are on the ellipse and we're not including the ellipse. So we're going to dot that. And then we got the circle there, and the circle is solid except at the y-intercepts. And then our solution is everything in between. Okay, so we label this. And that'll do it for checkpoint quiz 8.7.